Assalamu alaikum. Today we are going to discuss the hydroxides of period 3 elements. For F.Sc part 2. The chapter is S and P block elements. Now the hydroxides are the compounds, those compounds in which OH group, hydroxyl group, is either bonded ionically or bonded covalently to an element. Compounds in which the hydroxyl group is either bonded ionically or it is bonded covalently to an element. Now elements of period 3 are sodium, atomic number 11, magnesium, atomic number 12, aluminium, atomic number 13, silicon, atomic number 14, phosphorus, atomic number 15, sulfur, atomic number 16, chlorine, atomic number 17, and argon, atomic number 18. The hydroxides of these elements are sodium forms sodium hydroxide, NaOH, magnesium forms magnesium hydroxide, MgOH2, aluminium forms aluminium hydroxide, AlOH3, silicon forms silicon hydroxide, SiOH4, phosphorus forms phosphorus acid. It is written as POH3 or it can be written as H3PO3. Sulfur forms sulfurous acid and sulfuric acid, sulfurous acid H2SO3 and H2SO4. Chlorine forms hypochlorous acid HOCl or chlorous acid HClO2 or chloric acid or perchloric acid. The argon does not form any hydroxides. Now as we have defined that hydroxides are the compounds in which OH group is bonded ionically or covalently with an element. In the case of period 3 elements, sodium hydroxide, in sodium hydroxide and magnesium hydroxide there is ionic bond between sodium and hydroxyl group and magnesium and hydroxyl group, and in rest of the hydroxides OH group is bonded covalently to the elements aluminium, silicon, phosphorus, sulfur and chlorine. Now we discuss some of the hydroxides, important hydroxides of period 3. The first important hydroxide of period 3 is a sodium hydroxide. In these hydroxides of period 3, sodium hydroxide and magnesium hydroxide, they are basic in nature and they react with acids to produce salts. Like sodium hydroxide reacts with HCl to produce salt, sodium chloride and water. Similarly, magnesium hydroxide react with strong acids like H2SO4 sulfuric acid to produce magnesium sulfate, MgSO4 plus 2H2O. Aluminium hydroxide is amphoteric in nature. It shows both the acidic and basic properties. It can react with acids as well as it can react with base. It shows acidic property as well as basic property. Rest of the hydroxides from silicon to chlorine, they are acidic in nature. So as we move along period 3, the nature of hydroxides changes from basic to through amphoteric to acidic. So we discuss now some of the important hydroxides of period 3. The first hydroxide which we are discussing is sodium hydroxide. Sodium hydroxide is also known as caustic soda. The reason is that it is corrosive chemical corrosive in nature, and it can damage our skin, hair and wool by its chemical action. Sodium hydroxide is a white crystalline solid. Physically, it is white crystalline solid, and it is usually available in the laboratories in 3 forms. It may be in the form of granules, it may be in the form of sticks, or it may be in the form of tablets. It is slippery to touch. We feel slippery if we touch it. It is slippery to touch and dissolves in water to produce a slippery solution, which is also strongly alkaline, and dissolves in water, readily dissolves in water to give a solution which is also slippery to touch and also strongly alkaline. The solution is slippery to touch and strongly alkaline in nature. It is hygroscopic, which means that it can absorb moisture from air. When it is exposed to air, it can absorb moisture from air and becomes wet. The reason is that its aqueous tension is lower than air. Sodium hydroxide acts as a strong base, it is strong base, and that is why it reacts with acids and produce salts. For example, sodium hydroxide can react with HCl, NaOH plus HCl to produce sodium chloride plus water. It is so much stronger base that it can react with carbon dioxide of the air to produce sodium carbonate. So carbon dioxide is weakly acidic. It shows that it not only reacts with strong acids like HCl, but it can also react with weak acids like carbon dioxide to produce salts, which are known as, in this case, the salt formed is carbonate. Now, sodium hydroxide is prepared commercially by 2 different methods, but in both the cases involve the electrolysis of brine. There are 2 commercial methods for preparing sodium hydroxide. First one is known as the Nelson cell or Nelson process, and the second one is called the Kastner-Kellner process. In Nelson cell, when both the processes involve the electrolysis of brine, which is a concentrated solution of sodium chloride. For example, in Nelson cell, when we pass electricity through a solution of sodium chloride, aqueous solution of sodium chloride, when we pass electricity, then the following reactions occur. The sodium ions, they move towards cathode, chloride ions move towards anode, lose 2 electrons to produce 2 chlorine atoms, and these atoms then combine to produce chlorine gas, which is liberated at anode. Sodium ions move towards cathode, accept 2 electrons, converted to sodium atom, and these sodium atom then react with water molecules which are present in solution to produce sodium hydroxide solution and liberate hydrogen gas. Hydrogen gas escapes at cathode through a specific hole, and sodium hydroxide is collected in a catch basin. Now, sodium hydroxide is used for many purposes. Mainly, number one, it can be used as drain opener. Sodium hydroxide has dissolving power, therefore it can be used to open blocked drains. Second, it is used in rubber reclaiming. Reclaiming is a process of increasing the quality of rubber. And third, it is used for purification of petroleum. A mixture of sodium hydroxide and calcium oxide, it can act as carbon dioxide absorber, and it can be used for CO2 estimation during a process. It can be used to find out the amount of carbon dioxide which may be produced during a reaction. The mixture of sodium hydroxide and sodium carbonate, it is known as household lye, and it is used for washing cooking utensils. When it reacts with water, a highly exothermic reaction takes place. A large amount of heat is produced during the reaction, and this heat is then used to dissolve any oily products present in the utensils and cleans them up. Second hydroxide of the period is magnesium hydroxide. MgOH2. It is also known as milk of magnesia. And it is prepared by the reaction of potassium hydroxide with magnesium chloride solution. Magnesium chloride, soluble salt of magnesium, they can react with potassium hydroxide to give magnesium hydroxide. The reaction is MgCl2 in solution. It reacts with potassium hydroxide to produce magnesium hydroxide plus 2KCl. Magnesium hydroxide is basic in nature, therefore it can react with acids like HCl or H2SO4 to produce salts, MgSO4 plus 2H2O. It readily dissolves, its solubility in water is less. It is less soluble in water. However, its solubility can be increased by the addition of ammonium chloride. Ammonium chloride increases the solubility of magnesium hydroxide, increases its solubility in water. The reason is that when magnesium hydroxide is dissolved in water, it gives the following equilibrium. It produces magnesium ions and 2 hydroxyl ions, and this dissociation is very slight. But when we add ammonium chloride into this solution, it produces ammonium ions and chloride ions. Now, the ammonium ion which are produced by reaction 2, they remove hydroxyl ion from the mixture, from the solution, 2NH4 positive aqueous plus OH minus aqueous, and they produce ammonium hydroxide. Now due to reaction 3, as hydroxyl ions are removed by the ammonium ion, equilibrium 1 is pushed pulled to the forward direction, leading to more dissociation of magnesium hydroxide. Thus the solubility of magnesium hydroxide also increase. Magnesium hydroxide, like sodium hydroxide, is also a white crystalline solid. Magnesium hydroxide is used as anticonstipant. It is used as anticonstipant. Now we come to the third hydroxide of period 3, which is aluminium hydroxide. Aluminium hydroxide Aluminium hydroxide is gelatinous in nature. And it can be prepared by a reaction of aluminium chloride in solution with an alkali like ammonium hydroxide. We get AlOH3 plus 3NH4Cl by reaction of ammonium hydroxide with aluminium chloride solution. Or it can also be prepared by hydrolysis of aluminium chloride. Aluminium chloride is dissolved in water and it undergoes hydrolysis to produce aluminium hydroxide and 3HCl. Now aluminium hydroxide is amphoteric in nature. Amphoteric. Sodium hydroxide and magnesium hydroxide were basic in nature. Sodium hydroxide was strongly basic, magnesium hydroxide was weakly basic, but aluminium hydroxide is amphoteric. It shows both the basic property as well as the acidic property. It acts as a base and can react with acids to produce salts. For example, aluminium hydroxide plus H2SO4, we get Al2SO4 whole 3 plus H2O, 2AlOH3 and 3H2SO4, and here we have 6H2O. Aluminium hydroxide reacts with sulfuric acid to produce aluminium sulfate and water. It also shows acidic property and react with strong bases like sodium hydroxide, AlOH3 plus NaOH, and produces salts which are known as aluminates. We get NaAlOH4. Now it is called sodium tetrahydroxo aluminate 3. So they react with acids showing basic property, and they react with bases like sodium hydroxide to produce salts which are known as aluminates. Now this aluminium hydroxide can be used, it's used in permanent dyeing, the process of permanent dyeing. or mordanting. Mordanting. It is also known as mordant. Potash alum is used for the same purpose of mordanting, and the reason is that when potash alum is dissolved in water in the dyeing process, it ultimately changes into aluminum hydroxide. This aluminum hydroxide has a jelly-like nature. It sticks to the cloth and it causes the dye to be established on the cloth permanently. It fixes the dye permanently to the cloth. Now, rest of the hydroxides of period 3 are acidic in nature. Worth mention is silicon hydroxide, SiOH4. Silicon hydroxide is obtained, can be prepared by the reaction of silica with water or steam at 600 degrees centigrade. So we get SiOH4. But this silicon hydroxide is unstable and it may reverse the reaction. It may be changed back to SiO2 and water, or it may undergo polymerization. It may polymerize. It may polymerize during the process. Allah Hafiz.